Okay, so moving on to coenzymes in a metabolic pathways. Coenzymes is just co-worker, somebody that works along with. So they're going to be your helper proteins, or specifically your helper enzymes. The NAD plus coenzyme is required for metabolic reactions that produce carbon-oxygen double bonds, such as the oxidation of alcohols to aldehydes and ketones. So you can see here you have your ethanol, and you add your NAD plus, you have your alcohol dehydrogenase, ends in ACE, so this is your actual enzyme that's going to be doing the work. And then it breaks it down into ethanol, which is your product, and you can see that this hydrogen is added on, okay, as it's broken down. This hydrogen's missing from here, hydrogen missing from there, and so one of the hydrogen tacks on to become that hydrogen, then we have another hydrogen, okay? All right, so what about oxidation and reduction? Oxidation reactions involve a loss of hydrogen, a loss of electrons, and an increase in the number of bonds to oxygen, where reduction reactions involve the gain of hydrogen ions and electrons, as well as a decrease in the number of bonds to oxygen. So here's your nice little summary table, where you have your oxidation is a loss, loss, gain, increase, and your reduction is gain, gain, loss, decrease. So they're inversely related. Hi, Sophie. My cat's saying hi. You want to say hi? Hi, Sophie. Okay, sorry. So our coenzyme NAD+, these are helpers. So NAD+'s full name is nicotinamide adenine dinucleotide, and it's an important coenzyme in which the B3 vitamin, niacin, provides the nicotinamide group, which is bonded to ADP. Okay. NAD+ participates in reactions that produce carbon-oxygen double bonds. So you can see again here, we are going to have the double bond formed here, and we're going to be producing it, etc. The coenzyme FAD is flavin adenosine dinucleotide. This is a coenzyme that contains ADP and riboflavin, which is also known as vitamin B2. And it's reduced to FADH2 when the flavin is going to accept 2 hydrogens and 2 electrons. So, like, I teach them as taxi cabs. All right, so NAD plus and FAD, they're like empty taxi cabs. Their job is to take a hydrogen passenger down and drop it off at the electron transport chain, which we'll see coming up here. Okay, but just think of the empty taxi cabs are the guys that are being picked up, and then they're traveling and moving that hydrogen to the end of the cycle so that we can drop them off. But they're helpers. Okay, so with coenzyme FAD, it's going to participate in reactions that convert or change a carbon-carbon single bond to a carbon-carbon double bond. Okay, and in the citric acid cycle, the FAD is utilized in the conversion of a carbon-carbon single bond in succinate to a double bond in fumarate. Okay, so you have your single bond to your double bond. So what is the structure of coenzyme A? Well, coenzyme A, which is abbreviated CoA, contains a pantothenic acid, which is vitamin B5, and a phosphorylated ADP and aminoethylene thiol. Lots of words. Okay, so this is your coenzyme A. It's all of these all together. It's very big. So it's an important function of coenzyme A is to prepare small acyl groups, which are represented by the letter A, such as acetyl, for reactions with enzymes. So you have your acetyl group, your coenzyme A, and this helps turn it into acetyl-CoA, which is a thioester. And the thiol group, which is the SH bond, leads to a 2-carbon acetyl group that produces the energy-rich thioester acetylene-CoA. Acetyl-CoA. All right, so which of the following coenzymes best match with each of the descriptions? Pause me and come back. All right, so a coenzyme used in the oxidation of carbon-oxygen, that would be your NAD+. A reduced form of flavin adenine dinucleotide, so look for the starting letters FAD, and that would be FADH2. And a coenzyme that's used to prepare acetyl groups for reactions with enzyme is going to be your coenzyme A. An oxidized form of the flavin adenine dinucleotide would be the FAD. Again, look for those first words, FAD, first letters. And the coenzymes that after the C double bond O bond formation would be the NADH and the H+. All right, great job, you guys.